The hidden secret behind the avocado seed skin, an unexpected microscopic appearance. Take a closer look. Surrounding the avocado seed is a thin, brown membrane. Yes, the seed coat. There's a hidden world of shiny colors, strange, root-like structures, a cracked surface like barren soil, and even cavities like a dish sponge. Why is it all there? What's its purpose? And why does the seed coat sometimes cling tightly to the flesh, but other times it peels away easily? We're going to peel it all away, slowly, one by one. So brace yourself. Part 1. Why is there another skin inside the fruit seed? The avocado seed is already inside the fruit, protected by the thick flesh and hard rind. So why does the seed need its own rind? Isn't that redundant? The rind and flesh protect the seed from impacts, heat, and birds or large animals. But imagine when a ripe avocado falls to the ground. In the damp soil, the fruit begins to rot. The protective flesh becomes a threat, becoming a breeding ground for bacteria and fungi. This is where the seed coat comes into play. The seed coat is the embryo's personal covering, the last line of defense that keeps life inside the seed safe. It contains bitter tannins that deter fungi and bacteria. It also acts as a gatekeeper, regulating the entry of water and air, preventing the seed from germinating prematurely or rotting prematurely. Part 2. Brown that's not just brown. Now, take a closer look at the avocado seed coat at the beginning of the video. It's not just one shade of brown, is it? There's pale brown, light brown, and dark brown. The brown color of the seed coat comes primarily from tannins and lignins. Tannins are defensive compounds, bitter in taste, and can bind proteins. When the cells in the seed coat are alive, tannins are stored in vacuoles. As those cells mature and die in a programmed manner, the tannins are released, oxidized by the air, and turned into brown pigments. In areas where the cells are denser and dry quickly, oxidation occurs completely, resulting in a dark brown color. In areas where there's more moisture or less tannin, the color remains pale or light brown. Furthermore, some cells have walls thickened with lignin, giving them a harder, dark brown appearance. So, the irregular pattern of brown is a kind of map of the cell death process and the distribution of defense compounds. Part 3. The surprise of separating seeds from fruit flesh. Have you ever experienced separating an avocado seed from its flesh? Sometimes the seed coat peels off, but sometimes part of the seed coat sticks so tightly to the flesh that the flesh becomes stringy brown. Between the seed coat and the thin layer of inner flesh, there's a sticky substance called pectin. This pectin is like cement that holds the cell walls together. When the avocado is still unripe, the pectin is strong, so everything sticks together tightly. However, as the fruit ripens, an enzyme called pectinase starts working to break down the pectin. At some points, the pectin breaks down completely, allowing the flesh to separate smoothly from the seed coat. But at other points, the pectin remains, keeping the adhesive force strong. When we pull the seed forcefully, the thin seed coat can tear. Some remains in the flesh, some remains in the seed. The riper the fruit, the easier it is to remove. Part 4. Surprising colors. As we've seen under the microscope, there are unexpected colors. Besides the familiar brown, there's white, golden yellow, and even a silver sheen. Where does all this come from? The white color apparently comes from microscopic crystals. Many seed coat cells contain calcium oxalate crystals. These crystals store excess calcium. The golden yellow color comes from flavonoid pigments and a few carotenoids trapped within the parenchyma cells. These pigments may have played a role during seed development. Then there's the silver color. This is an optical phenomenon. In some areas, there's a very thin layer of dead cells that collapses, forming flat air cavities. When the light from the microscope hits the boundary between the transparent cell wall and the air below, total internal reflection occurs. The effect is much like a natural mirror, producing a silvery sheen. Part 5. The mysterious root-like network. There are branching structures, spreading like fibrous roots, embedded within the seed coat tissue, just as we see them today. These root-like structures are the vascular system, or tissue. that was vital when the seed was still forming. When the avocado was still a flower and ovary, the ovule received nourishment from the parent plant through a connecting stalk called a funiculus. From there, vascular bundles penetrated the seed coat to deliver water and nutrients to the growing embryo. These vessels branched finely, forming an intricate network. Once the seed matured, their work was complete. The surrounding parenchyma cells shrank, but the xylem, whose walls were reinforced with lignin, remained intact, leaving behind a brown skeleton that looked exactly like tiny roots. So, what you're seeing is a fossilized food supply system. Part 6. Barren land and the magic sponge in the seed shell. We must have seen what looked like barren soil. These are the epidermis and subepidermis layers, which have completely died. The cells here have lost their contents, and their walls are thick and rigid, coated with lignin and suberin. As the seed dries, this layer shrinks unevenly, creating cracks and irregular patterns. Then there's the spongy area, where these cells form large, interconnected intercellular spaces. When fresh, these spaces are filled with air or mucus. After drying, the cell walls retain their hollow framework. This retains air and absorbs water, allowing the avocado seed to float. Thank you for watching. See you again.